Welcome to D20-106, where we're going to discuss the DTA, or the Data Translation Application Overview. In this data translation application, which was created by GE to service our customer needs in specific sectors. So for example, we can service them in the generation, transmission, and feeder bay automation, in the distribution automation applications, in the alternating current monitoring, or to monitor the communication between the RTU and other devices. Also, it's used for data logging, storage, and historian applications, and data reduction and summarizing. Finally, it can be used for data conversion. So there is a lot of data that's coming to the remote terminal unit, and before we transmit it to the operator, we have to manipulate or change this data and put it in a very summarized way that the operator can make a smart decision about it. So that's basically what a data translation application takes: information from the database, change it, and then places the information back into the database to either information about the data, so the state can be converted. Like for example, if it's a 0 that's coming from the field and to the device, that means it's an offline, and 1 is going to the master, needs to go to the master, because 1 to the master means it's an offline. So this application would change a 0 state to a 1 state. That's basically when we convert a state. Also, it can be used to show a behavior. So when communication is lost between the main chassis and one of the devices in the field, you can associate that with a digital input in the DTA that will tell you that this communication has been lost, and you place basically a communication watchdog application. So there is lots of applications that over the year the customers have approached GE to develop in order to make it easier for them to implement in the field and to execute at a very fast speed, which is the key in our fast operating embedded systems. Let's get to the first section on the D20 or D25, D200 DTA overview. Over the years, GE have developed many applications for the automation platform. Well, the application that we are interested in today is the data translation application, or DTA. The DTA has been developed for many platforms. For example, the D20M, M++, M+, ME, ME2, MX, D200, D25, iBox, and the iBox kit. And in all of these platforms, more or less the DTA would do the same job. Some DTAs were developed for specific platforms, for a specific customer, and carry the customer name. Some DTAs were developed across all the platforms, so it works in the iBox, in the D25, in the D200, in the D20. Some applications were very generic, some of them very specific to the industry. So for example, some of the generic applications that we give to every customer who purchase a D20 system or a D25 or an iBox is the calculator application, A083. And it's a very useful application, very powerful. You can build logic in it. You can build very complex logic in it. I've seen customers with building something that as complex as a requirement for a ladder logic inside calculator. Also, we've got the ProLogic and the Logic Links application, which were developed over the year to allow customers to program using IEC standard programming languages, and that allowed the customers to put ladder logic functional diagrams inside the D20. The D20 is a very powerful box that allow you for execution of these of that logic. So what happened is customers would find a certain logic to be useful in the field, but they require it to be executing efficiently and not via the interpretation of the ladder logic. So they would approach GE in order for us to create a specific DTA for their industry sector. GE would evaluate it, and if we found it that it is common to a lot of customer base, we would have developed this DTA. Now, what you have to know as a user of the remote terminal unit is that if you're thinking of a certain application or a certain logic, let's say you want to OR all your digital inputs, we could have a DTA that will service your need. For example, Common Alarm DTA, Data Translation Application. And the Common Alarm DTA will allow you to take a whole bunch of digital inputs and change them into a single alarm point, all right? There is many applications that serve the generic need, and there is applications, like we said, that serves the specific need. So, for example, there is also the substation maintenance application, which means that you turn this on, and then no alarms will be transmitted to your operators while maintenance is taking place, right? So you don't want false alarms at your operators. Okay, so now hopefully you have an understanding that these applications exist in not in all the platforms, in some of the platforms, and some of the applications are generic, so they have a generic application. Some of them are very specific. So I'll try to demonstrate throughout this discussion that the specific one that are useful per industrial sector. The information would be created in the field as digital information from a sensor or a meter that's measuring something, or a relay that's taking certain important action, or from a peripheral like an I/O card that is connected to these sensors or inputs from the field. Once the information is available in the field, it's then formatted in a protocol and transmitted to the physical port that it is connected to. That physical port could be either a serial port or a network port. There is an application that's constantly monitoring that port for information that is of interest, which is the data collection application family of protocols. So it could be either a DMP data collection application, or a Modbus data collection application, or a 101 data collection application. That data collection application would take that information that is received from the physical port, decipher it, figure out the important information that needs to be stored in the WIN database, places that information in the WIN database. Now what we have inside our WIN database is physical data that we received from the field. That information would then be pulled out by a data processing application. The data processing application would format the information in order to send a reply. The reply will go to the communication port, the target physical port that is connected to a master. The master would receive this information that's of interest and then present it to an operator. One thing to note here is that if the information that's received from the field inside the WIN is not the information that the master wants to view, or the master requires that information to be manipulated or changed, then that is where the DTA come into play. The DTA picks up the physical information, change it, manipulate that information, and then put it back into the WIN database, right? The DTA has other strengths where it can monitor the communication. So it can monitor the communication between a data collection application and an IED, and whenever it sees no activity or there is a drop of a certain RS-232 signal, it can raise a digital input point or an alarm. So in this case, it's putting information not about physical information that was received in the field, but behavioral information that will talk about certain status that took place in the remote terminal unit. It can also pick up information or make information available to masters so that masters can behave or issue commands as required. So for example, it can stop or lock a master from sending a digital output to the field if that master doesn't have control of that digital output on the field, and I will elaborate on these applications. This section will discuss the generation, transmission, and feeder bay data transmission applications. In the data translation application generation and transmission, the applications that are available include the definite time protection, so over time, how many multiple of pickups took place, breaker failure protection. So it's similar to the protection that's that happens in a relay, but you can do it in a bay. Synchronism, that's basically synchronizing the voltage between two buses. And local remote switch setup. Normally we have a manual local remote switch, but you can also implement a software local remote switch, automatic voltage control, secondary master trip close, set point adjustment, tap position indication, and automatic load restoration. In this section, we'll provide you a brief idea of the available applications in the distribution automation sector. For a distribution automation, some of the applications, as you can see in the example, will include an auto recloser and automatic restoration when there is an outage out there. How can the intelligent electronic devices figure out how to restore the power? And to do that, they would rely on bays and like the D25 bays, or intelligent electronic devices like the D400 or the D20, and applications DTAs like a distribution capacitor control algorithm or fault localization, load and dead bus transfer, load shedding curtailment applications are all examples of DTAs that has been developed and available, so you don't have to build the logic in your logic links, as we said, or your ladder logic in order to carry out this very complex logic. Instead, all the logic has been built. You can just request the application and include it in your list of tools that can be used in your substations. In this section, we're going to discuss alternating current data translation applications. For the AC applications, the AC applications that were developed for the DTA include the AC analog alarm data translation application that basically provides alarms based on certain AC values. Data profiling data translation application, and power quality data translation application. The digital fault recording application, the supplementary AC data application, thermal demand metering application, and last is the statistical data application. Okay, next we will list the applications that are available for communication monitoring. As you can see in our demonstration for the communication monitoring, for example, there is a communication watchdog application, and the designer decided to create it using this bulldog or watchdog that basically signify that when there is a message or a communication loss, that alarm is generated by this data translation application. Earlier I mentioned the substation maintenance application, which basically stops any alarms going from the substations when there is work being carried out in the substation, so that to avoid false alarms going to the operator. The virtual terminal or the pass-through is a great application. Sometimes you have a software that basically wants to connect to a field device, but it cannot deal with all the inter gateways and inter remote terminal units. So this pass-through application would allow that software to feel as if it is connecting directly, even though it's going over multitude devices and network from one point to the other. LAN services applications, communication statistics in order to measure how much loss of messages took place. Of course, the time protocols, which include the IRIC-B, the HOP, the SNTP time, and finally the data display applications, which sits in like a bay or in a D20 chassis and basically displays the data using an interactive touch screen. These are some of the communication monitoring applications that's available for the field services. In this section, we'll briefly discuss the data logging, storage, and historian applications. In substation, normally the data is very constant, but sometimes the data do change over time. So when there is a change in data, it raises an interest for the operator. So if the data is changing without a time tag, you cannot put the sense around what happened first, what happened second. So you cannot put it in a sequence. So a change of state without time, we call it a COS. We refer to it as a COS, or a change of state sometimes. And change of state with time, which means you can put it in sequence, so every change of state that takes place is logged into a database, into a historical database and event database. You can look at it, and then you can put the events and sort them by time. That's a sequence of events, so it's referred to as SOE. The SOE logger would allow you to collect that data and put it in a file that can be uploaded from or downloaded, whichever way you look at it, from the chassis, and then it will allow you also to print that information to a nearby printer if required. So that's the job of an SOE logger. An accumulator freeze DTA is an application that will allow you to periodically get a snapshot of the accumulators or the counters as they continue counting, and you want to make sense of the data over a period of time. So periodically it will take that snapshot and make it available to be loaded or analyzed. And of course, all of this can only happen if we have an event storage and a historical analog system, that analog and digital system that keeps logging this data and save it for us to analyze this data. In this section, we're going to briefly discuss the data reduction and summarizing data translation applications. So some of the applications that will assist you in reducing the data and summarizing it so that we can make sense of it include the analog reference data translation application, the data change detect application. If you're only interested in the changed information, not in the static information, alarm prioritization, analog averaging, analog alarms, top of the hour or TOH, analog averaging, redundant IO, which allow you to get data from two sources. If one source failed, then you can get it, or also to compare that the value that you're getting is really what you should be reading. And the debounce monitoring. I talked about debounce in earlier modules, which is basically when data is changed in a very small period, whether that change is significant to log or notify of the change, or just ignore that little debounce change. In this section, we're going to talk about data conversion applications. In a substation environment, there is always a need for converting either analogs to digital or digital to analogs, or convert an input to an output or an output to an input. convert the type, whether it is 12-bit to 16-bit, 16 to 12, or so forth, and like 32 to 64-bit. And sometimes the data comes without a timestamp, so you need to timestamp it upon receipt of the data. So all of these applications or needs that showed up over the years, the customers have approached GE for a special data translation application that will help you do these conversions without the need to write the logic, and you can see the list of applications that will assist you in this field. Just to summarize, you don't need to create the logic yourself. Most of the logic sometimes have been already created and ready and available for your application. There is documents that are available that will list all of these applications. We just went through a brief discussions of the available applications in the for the D20 or D200 or D25 iBox family. And what we covered was a brief listing of these applications so that you're aware of the available applications that you can request from our development team if needed, and the applications including applications that belong to the generation, transmission, distribution, analog, AC analog monitoring, communication, and then all the data manipulating applications for summarizing and conversion. Thank you for being with me, and hope to see you in future modules.